Light is a form of energy. Light is needed to see things. We cannot see an object in the darkness of night. We need a source of light to make the object visible. We can detect light with our eyes. Objects which give out their own light are called luminous objects. Objects that do not emit light of their own, like chair, table, bird, plant, etc., are called non-luminous objects. Property of light by which it travels in straight lines is called rectilinear propagation of light. The process of sending back the light rays which fall on the surface of an object is called reflection of light. Most of the objects reflect the light falling on them. When this reflected light reaches our eyes, we are able to see the objects. Laws of reflection.
Terms related to reflection. A ray of light when falls on a plane mirror gets reflected. Is the reflecting surface. Incident ray. The ray of light which falls on the mirror's reflecting surface is called the incident ray. The ray of light AO is the incident ray. The incident ray always goes towards the mirror. Point of incidence. The point at which the incident ray strikes the reflecting surface of the mirror is called the point of incidence. The incident ray AO strikes the reflecting surface of the mirror at a point O. Therefore, O is the point of incident. Reflected ray. The ray of light which is sent back after reflection by the mirror is called reflected ray. OB is the reflected ray. The reflected ray always goes away from the mirror. Normal. The normal is a line drawn at the right angle, perpendicular to the mirror surface at the point of incident. The dotted line OM is the normal to the mirror surface MM at the point of incidence O. Angle of incidence. The angle which the incident ray makes with the normal at the point of incidence is called the angle of incidence. Angle AOM is the angle of incidence. It is represented by the letter I. I is equal to incidence. Angle of reflection. The angle which the reflected ray makes with the normal at the point of incidence is called the angle of reflection. Angle NOB is the angle of reflection. It is represented by the letter R. R is equal to reflection. The laws of reflection of light are as follows. The angle of incidence is equal to the angle of reflection. The incident ray, the normal and the reflected ray all lie in the same plane. Formation of images by a plane mirror. When we look into a plane mirror, we see our image situated behind the mirror. When we move towards the mirror, our image also moves towards the mirror, and when we move further away from the mirror, our image also moves away from the mirror. In every case, the distance of our image from the mirror is equal to our distance from the mirror. Let's prove this fact geometrically by drawing ray diagrams and using the laws of reflection of light. When object is a point source of light, a point source of light O is placed in front of a plane mirror PQ. The rays of light starting from point O travel in all directions. Consider two directions, OA and OC, starting from point source O, which obey the laws of reflection and get reflected along AB and CD. Draw normal to the surface of mirror PQ at the point A and C. Then draw the reflected rays at the point A and C. AB and CD are reflected rays. Extend them backwards. They meet at the point I. For a viewer's eye, at E, the reflected rays AB and CD appear to come from the point I. Figure 6.7. Since the reflected rays do not actually meet at eye, but only appear to do so, we say that a virtual image of the point O is formed at eye. If we join OI and measure OL and LI, it is found that they are equal. This proves that image is formed as far behind the mirror as the object is in front of it.
Regular and irregular reflection.
When we hold a plain mirror in front of us, we see our face in it. This is because the entire light that falls on the surface is reflected in a definite direction. Such a reflection is called regular reflection.
The phenomena due to which a parallel beam of light on striking a smooth, highly polished surface, like a plane mirror, is reflected back as a parallel beam of light is called regular reflection of light.
When we hold a cardboard in front of us, we are not able to see our faces in it. This is because the entire light that falls on the surface is reflected in all directions, irregularly, in a scattered manner. Such a reflection is called diffused reflection.
The phenomena due to which a parallel beam of light on striking a rough surface, such as cardboard, gets reflected in various directions is called irregular or diffused reflection. Differences between regular reflection and irregular reflection. Parameters, points of difference, nature of reflecting surface, reflected rays, image formation. Regular reflection. The reflected surface is smooth and highly polished, like a mirror. All the parallel rays reflected from a smooth surface are parallel. Images, like seeing our face, are formed. Irregular reflection. The reflected surface is not smooth but irregular, like a cardboard. All the parallel rays reflected from a rough or irregular surface are not parallel. Images are not formed. We cannot see our face on a rough or irregular surface. Multiple images. When two mirrors are inclined to each other at an angle, many images of the object placed before them are seen. This is because the image formed in one mirror acts as the object for the other. Many images formed in this manner are called multiple images. Kaleidoscope. The kaleidoscope is a device that uses reflections to produce patterns. It consists of mirrors inclined to each other. The mirrors form multiple images of objects in front of them. This creates beautiful patterns, which changes when the kaleidoscope is rotated or shaken. Dispersion of light. The phenomenon of splitting of white light into its component colors on passing through a transparent medium like a glass prism is called dispersion of light. The band of 7 colors formed on a white screen when white light passes through a prism or any transparent medium is called spectrum of white light.
Human eye. The human eye is a light-sensitive organ which enables us to see the beautiful world around us. The eyelids act as the shutter of the eye and protect them from injury or prevent any object from entering the eye. It also shut out light when not required. The eyeball is almost like a spherical ball. It has a diameter of about 2.3 centimeters. The outer part of the eye is composed of 3 layers of tissues, namely sclera, choroid, and retina. Sclera. It is the outermost covering of the eye. It is made of white, tough, fibrous tissues. It protects the vital internal parts of the eye. Cornea. The sclera layer continues in the front of the eye as the cornea. This is a transparent white portion of the eye which covers the transparent bulge on the surface of the eyeball. It allows the light to enter in the eyeball. Iris and pupil. Behind the cornea is the iris. It lends color to the eye. The iris has a central circular aperture called the pupil. The iris regulates the amount of light entering the eye by adjusting the size of the pupil in the following ways. A. If the light is dim, the iris makes the pupil expand in order to allow more light to enter the eye. B. If the light is bright, the iris makes the pupil contract in order to decrease the amount of light entering the eye. The iris consists of muscles that expand and contract the pupil. Choroid. The dark grey layer attached to the sclera on its inner side is called the choroid. It is richly supplied with blood vessels. It darkens the eye from inside and hence prevents any internal reflection. Crystalline lens. It is a transparent crystalline biconvex lens situated just behind the iris. It is held in its position with the help of ciliary muscles. Retina. It is the innermost delicate membrane having a large number of nerve cells called rods and cones. The cones are sensitive to color, while the rods are sensitive to the intensity of light. Optic nerve. Optic nerves are about 1 million separate nerve fibers that connect the rods and cones of the retina to the brain. Its function is to carry optical messages in the form of electric signals to the brain.
Working of the human eye. The light coming from an object enters the eye through the cornea and the pupil. Light coming from an object enters the eye. The lens focuses the light rays to form an inverted image on the retina. Rods and cones of the retina get activated and generate electric signals. Optic nerves send electric signals to the brain. The brain interprets these signals and renders the erect image of the object. Blind spot. At the junction of the optic nerve and the retina, there are no sensory cells, rods or cones, so no vision is possible at that spot. This is called the blind spot of the eye. Persistence of vision. When the light coming from an object falls on the retina of the eye, the impression of an image does not vanish immediately from the retina. The impression of the image lasts for 1/16th of a second. So, if still stationary images of a moving object are flashed on the eye at the rate faster than 16 per second, then the eye perceives this object as moving. This is called persistence of vision. Power of accommodation. Power of accommodation. The ability of the eye lens to adjust its focal length so as to see the objects located anywhere is called the power of accommodation. The minimum distance at which the eye can see objects very clearly without strain is called the near point of the eye. The farthest point up to which the eye can see objects clearly without strain is called the far point of the eye. Defects of vision and their correction. Sometimes the eye may gradually lose its power of accommodation. In such conditions, the person cannot see the objects clearly and comfortably. The common defects of the eye are the following: nearsightedness or myopia. A person with myopia or nearsightedness can see nearby objects but cannot see distant, far-off objects distinctly. To correct a myopic eye, the person has to use spectacles with a concave lens. Farsightedness or hypermetropia. A person with hypermetropia or farsightedness can see distant, far-off objects clearly, but cannot see nearby objects distinctly. To correct a hypermetropic eye, the person has to use spectacles with a convex lens. Cataract. It is a leading cause of blindness among the adults of 45 years of age and older. The eye lens becomes cloudy. Because of this cloudiness, light rays do not pass easily through the lens to focus on the retina. As a result, things look foggy or cloudy. People with cloudy eye lens are said to have cataract. Care of eyes. Always sit straight while reading or writing. Do not read while lying down. It strains the eyes. Always read at the normal distance for vision. Do not read in a dim light or very bright light. Insufficient light causes eye strain and headaches. Do not watch television or read for a long time. Sit at least 6 feet away from television set. Technological aid for the visually challenged people. Braille system. Visually challenged people can read books printed in Braille. Combinations of raised dots in a 6-dot cell make up different characters. Louis Braille, who lost his sight when he was a child. Books and periodicals are available in Braille for the blind.